Hello, everyone. Welcome back. Make sure that you have your identities handy from your Google Drive folder, or if you happen to have most of them memorized, even better. That will pay off huge dividends in your calculus sequence. Now, in the video before this one, we looked at simplifying expressions with trig functions involved. What we're going to do now is we're going to move up to verifying, and we'll have an equal sign where we're going to show that one side, through the use and manipulation of identities, can be written as the other side. There are several techniques involved. I usually go from the harder side to the easier side. So let's take the left side of this equation, and we're going to try to make this turn into that. The left side of the equation, secant squared theta minus 1 over secant squared theta. Using your Pythagorean identities, there's one in there that is 1 plus tan squared equals secant squared. You'll find it in the Pythagorean identities. If you subtract 1 on both sides, then tan squared can be used to replace secant squared theta minus 1. Again, in the Pythagorean identities, find the one that's 1 plus tangent squared theta and rewrite it from secant squared minus 1. Tangent squared using quotient identities is sine squared theta over cosine squared theta times 1 over secant squared theta, which is the reciprocal of cosine squared theta. Tan squared theta you can write using this ratio or fraction times 1 over secant squared theta. Its reciprocal is cosine squared theta. You get a nice cancellation of your cosine squared thetas, and that leaves sine squared theta, which was the other side of the equation. Another way you could do this, because there's many ways to show these. If I happen to pick a way that you don't, it's not going to be a problem. If it's just an open, I ask you to show one side equals the other, you pick whichever way works, as long as you use your identities and math appropriately, it's legitimate. All right, now another way you could have done this was to separate this into two fractions, secant squared theta over secant squared theta minus 1 over secant squared theta. Secant squared theta divided by itself is 1. 1 over secant squared theta is cosine squared theta. From your Pythagorean identities, 1 minus cosine squared theta is equal to sine squared theta. It's a different way, but equally as good way to show that verification. Let's verify that 1 over 1 minus sine alpha plus 1 over 1 plus sine alpha is equal to 2 secant squared alpha. I'm going to start with the harder side. The sign difference requires us to use both denominators as the common denominator. So I'm going to multiply the first fraction by 1 plus sine alpha and the second fraction by 1 minus sine alpha. That will create a common denominator. Multiply carefully. That's 1 plus sine alpha plus 1 minus sine alpha. 1 plus 1 is 2. Sine alpha minus sine alpha is 0. And then if you were to FOIL the denominator, you would get 1 minus sine squared alpha. The O and the I part from FOIL cancel one another. 1 minus sine squared alpha, using Pythagorean identities, can be rewritten as cosine squared alpha. And that's the reciprocal of secant squared. So this fraction becomes 2 secant squared alpha, which is the other side of the equation. Let's verify tan squared x plus 1 times cosine squared x minus 1 is equal to negative tangent squared x. You could FOIL these, but using Pythagorean identities, these two terms can be written as secant squared x, and these two terms, with careful manipulation, can be written as negative sine squared x. Secant squared x is the reciprocal of cosine squared x. So negative sine squared x on top. Using the reciprocal, we can put cosine squared x on bottom. Sine over cosine is tangent, so sine squared over cosine squared is tangent squared. Don't forget your negative. Tangent x times cosecant x is equal to secant x. Tangent x through quotient identities, you can write that as sine over cosine. From reciprocal identities, cosecant is 1 over sine. The sine x's cancel, leaving 1 over cosine x, which is equal to secant x. Tangent x plus cotangent x is equal to secant x times cosecant x. Let's show that. Tangent x is sine over cosine. Cotangent x is cosine over sine. Excuse me. The two denominators are not alike, so we force a common denominator by multiplying in a sine x top and bottom on the first fraction and a cosine x top and bottom on the second fraction. Multiplying top and bottom by sine x, you get sine squared x over cosine x sine x. Multiplying in a cosine x top and bottom, you get cosine squared x over cosine x sine x. Common denominator, write that, and then add your numerators. Sine squared x plus cosine squared x, that's equal to 1. 1 over cosine x times 1 over sine x, basically splitting, but don't forget it's multiplication. So you can split them, but you got to keep multiplying. And that's secant and cosecant, and that's what we were asked to show. I hope this video helps. Please reach out with any questions or concerns by email, phone, or stop by the office, and I hope this helps.